Heat up. I don't get it.
Don't worry, guys. I know y'all don't get it yet. We're gonna be talking about it next week. Do we have?
Am I missing something? I don't get it.
All right. Biochemical processes. So, what temperature is our body at?
90 something.
98.6. 98 point what day? 98.6. You guys learned that in biology.
You said bio what?
Biochemical reaction or processes. So, in our body, you know, there's so many reactions that go on, and some of them require heat. That's why when you get sick, your body heats up because it's trying to get rid of whatever's in there. So thermodynamics is really important when it comes to the process that happen in our body. And then the last two says chemical reactions. As you guys know from chemistry from last year, when you did some reactions, you had to put it on a hot plate, right? And heat it up. We have to cool it down. You guys will do that. You guys will do that next year in Chem 2 as well. And then structures of stars for you guys who like astronomy. So stars are balls of hot gas. So thermal is very important for that too. Alright. So do you guys think thermodynamics is pretty important, you know?
Yeah, of course.
Alright, now
I'm
let's
glad you guys think about it. That's why it's important. Alright, we're gonna come back to the laws of thermodynamics at the end actually. So what I want to spend this time talking about now is temperature. So temperature is the qualitative hot or cold. How hot is something? How cold is something? Just like everything has a color, everything has a temperature. And that temperature is basically a measure of how hot or how cold it is, which is different from the amount of heat.
Isn't Bob Crosby? Ain't he the modified what you call it? Like temperature. You know what I'm saying? Like depending on the temperature, you know how much like heat.
Good
Mr.
job.
Fisher, do we have to do the examples?
No, don't write the examples.
Mr. Fisher, you think we have school tomorrow?
Well, look,
Or the last-
Supposed to snow tomorrow.
No, but it's supposed to be the last-
to be like 8 degrees.
Let's try that.
Zero.
So, and many things we measure depend on the temperature. So for instance, the length of something depends on temperature. The ability of a wire, you guys back there? The ability of a wire to conduct electricity depends on temperature. Next year, we're gonna learn that when you increase the temperature, metals conduct electricity less. And then the color of objects, but most importantly, the most important thing we care about is what to wear to school based on the temperature, right? You know, I don't see any of you guys wearing shorts today.
Oh no, boy, my job was shorts every
You
day.
guys are supposed to lie.
This boy in school wears shorts every day. Why?
But what I do want you guys to do is write down this last point. Temperature is related to molecular motion. And we're going to be talking about that point next week.
Huh? Oh, we recording.
And what do we use, what do we measure temperature with?
A thermometer.
Good job, Destiny.
I was gonna say degrees.
We measure, no, that's a good answer too. We measure temperature based on a thermometer. Now, back here, I have a demonstration where I just started boiling water, and I have one type of thermometer you guys are used to. This is not the only type of thermometer there is. This is just one. And can someone raise your hand and tell me how this works?
You stick it in, the red thing go up. What is it?
Why does the red thing go up?
It's
Because
expanding
the
and
freaking hot
compressing.
is trying to escape the.
Yeah, it is mercury.
Say that one more time, Carl, but a little bit louder.
It's either expanding or compressing.
Great job. And we're going to be talking about that more tomorrow. So if I put it in here, do you guys see the little red mercury going up?
Yep.
All right. And when I put it in the cold water, it goes back down. So when I heat something up, does it expand or does it compress?
Expand.
Expand. In the summertime, when you guys have tried to open up your doors, like in your house, do you guys notice that sometimes it's hard to open up the door or it's hard to close the door sometimes? It like doesn't fit all the way, like perfectly?
No.
Yeah, that's my favorite.
And that's because your door, that material actually expands. So your door gets slightly bigger in the summertime. In the wintertime, it's a little bit more loose because when you lower the temperature, the length decreases. I have a question up there. What's up, Tania? I mean, Journey. What's up, Journey? Oh,
I
yeah.
have a question
Yes.
though. How come that's different? Because like you know how you put a water bottle inside the freezer and it expands? I know it's the polymolecules, but isn't it true that it can change because even though it's heat and it expands, and the cold expands the water bottle too.
Interesting. I'm gonna get back to you on that question because that's a very good point. All right. And you know, part of that, Kamari, might be because of a phase change. Because you know, since though it went from liquid to what? Solid. So when that happens, the volume gets a little bit bigger. In the examples I just gave, it was still in one phase. Shh, I need you to be quiet back there, Tara. All right. Now, I want you guys to write down
Wait.
this second and third bullet. So this first thermometer is this first picture, which is a thermometer, is the one I just showed you. We have a liquid, and then based on temperature, the length will expand or contract. This is another type of thermometer. One, because you guys learned last year in chemistry that pressure and temperature are related. So this gives you temperature based on a pressure. So this reads pressure and temperature. And we have another thermometer where we can use resistance. So if we measure the resistance, we can know which temperature a piece of metal is at. Temperature and pressure. And this last bullet just says we can use length, pressure, and resistance to make a thermometer.
We gonna make a thermometer?
No, we're not gonna make a thermometer, but we are gonna do a cool lab at the end. But if you guys take my class next year, we're gonna be talking about electricity and magnetism. The second and third bullet. All right. On a scale from 1 to 5, how do you guys feel about your understanding of thermometers now? Yeah, I see a lot of 5. Some people still writing, Deshaun, how do you feel? 1 to 5 or 5 to 6 is great. Good job. Do I have any questions on thermometers?
Do modern thermometers still have mercury in them?
Yes. So some of them do, but some of them, what they do is they measure like electricity and stuff too. So different thermometers like do different. We use it depending on what we need it for. Will depend on the type of thermometer that we use. All right, and you guys have one thing that you guys have been doing a really good job at is writing down your notes. And on the midterm, you guys really impressed me with how much information you retain in choosing the proper equations and putting things into your calculator. So great job. All right, so we know that we have 3 different types of scales: Celsius, Kelvin, and Fahrenheit. Which one do we use in the United States? Don't worry, guys. I get confused on this one sometimes. We use Fahrenheit. Which one do they use in all across the world?
Celsius.
So the United States has to be super special and go ahead.
We the only one to use Fahrenheit.
Yes.
Let me think it's better than everybody. It's Q2 and Fahrenheit.
So, but the SI unit is Kelvin. So this is the one that a lot of people use in the scientific community. So Kelvin. So I want you guys to write down these 3 equations because this is how you go from Celsius to Fahrenheit to Kelvin.
I know it's plus something.
And if you guys look carefully, the second equation is just the first equation rearranged. That's why I drove algebra skills with you guys, and your algebra skills have gotten significantly better.
started at Fahrenheit?
Yeah, like when it's zero, when it's zero, then you don't have to go outside.
Oh, true.
What's the number in the first one?
They're up. This is 9/5 C. Also, there's a typo. There should be a C right here. For Kelvin, there should be C plus 273.15. C. Right. Not 32. There should be a C.
It's 32.
No, it's just C. Kelvin is just your Celsius plus 273.15. That one's the easiest conversion because you just have to add. Alright, so I'm gonna go through an example with you guys now. Did you guys get that? The second one says 5/9, and in parentheses, Fahrenheit minus 32. Say it again. So right here should be C. This 32 should be a C, not 32. You're
In
welcome.
the 30 equation?
In the third equation, yep.
Thank you.
Now I have a question. For equation 1, do I multiply C times 9/5 and then add, or do I add first?
Multiply.
Multiply first, good job. What about that second equation? Do I multiply or subtract first? Okay, great job. So I'm gonna go through these examples with you guys. Also note the typo. Did I actually have one? So, actually for that first one, what I'm gonna do is change that to, what's the temperature outside today?
Like 30 something.
33 degrees. So, I want to go from 33 degrees Fahrenheit to Celsius. So, going from Fahrenheit to Celsius. So, I need to use this equation because I'm looking for Celsius. So, C is equal to 5/9 times F minus 32. So then I do 33 minus 32, which is just 1. So 1 times 5 divided by 9. And that gives me 2.78 degrees Fahrenheit. Note that the little degree symbol goes before the letter. Oh, sorry, degrees Celsius. Sorry. So 33 degrees Fahrenheit is equal to 2.78 degrees Celsius.
I don't know, this is chemistry.
Yep, this is the foundation of thermal. What's up?
Can I divide 5 divided by 9 and then, can I put my calculator like that?
Mm-hmm.
And then,
Very good question.
oh,
And then, to the second one, we're going from 39 degrees Celsius to Fahrenheit. So 39 degrees Celsius, which that's the temperature right now in Australia. If you look right here, where the temperature we have is 2.78 degrees Celsius. Australia is 39 degrees Celsius. So if I want to go to Fahrenheit, it's going to be 9/5 times 39 plus 32, which should give you approximately 102 degrees Fahrenheit. So this is how hot it is in Australia. 102 degrees Fahrenheit. That's pretty cold, isn't it? Is that cold or hot?
That's hot.
Hot.
I'm just checking to make sure. I'm just checking to make sure.
So what you gotta do?
Say it again, Tara.
So actually, you count the lost me.
So right here, I went from Celsius to Fahrenheit. So if I'm going from Celsius to Fahrenheit, which equation do I use?
Oh, from Celsius to Fahrenheit. Don't use Fahrenheit. The F equals.
Exactly. And I just plugged this into here. Does that clarify the question?
No, I don't know what I was
Okay.
I don't know, that one, 33 minus 32 is 1. Can you just multiply 5 9 by 1?
No.
That's, I didn't get that.
That's what I got.
It's
I
point.
plugged in the other one, it doesn't work.
Oh my gosh. Wait, hold on.
What you did was you divided it by 9, you just multiplied by 9.
Oh, my apologies. This should be 0.55.
Oh, I'm saying.
Thank you so much, Austin, for catching that mistake. 0.55 degrees Celsius. So, we're 0.55 degrees Celsius. Australia is 39 degrees Celsius. So they're a lot hotter than we are right now. And then, for this last one, now, for this last one, I have to go from 295.92 Kelvin to Fahrenheit.